Let's do numbers 4 and 5 from the study guide. So this one says, select all equations that have b equals 7 as a solution. Show your work to support your choices. So we want to show work for every single one. All right, a really simple way we can do this is just plug in b equals 7 and see if it's true. What I mean by that, if it makes a true statement. So let's see. Since b has to equal 7, we just plug in b in place of 7. So 7 times 4 equals 54. Let's see if that's true. 7 times 4 is 28. Does 28 equal 54? It does not, so I would say that is not a solution. Now your other way is you can actually just solve for b and see if it equals 7. So to do that, we would do the opposite, the inverse, right? The opposite of multiplying by 4 is dividing by 4. And that would tell us b equals 13.5. which isn't 7, right? So that would also not be true. All right, moving on to the next one. So I'm going to do 4 minus 3. Oops, sorry. I don't know why I did 4. Should be 7 since b equals 7. 7 minus 3 equals 20. And 7 minus 3 is 4. 4 does not equal 20, so that would not be a solution. Once again, let's show the other method. b minus 3 equals 20. The opposite of subtracting 3 would be adding 3 to both sides. And b would have to equal 23, which of course, that's not 7. So that's also not a solution. Try the next one. We can plug in 7. So 7 plus 7 equals 14. What does 7 plus 7 equal? That equals 14. That seems to be true. And the other method, we would just plug in 7 in place of b. 7 plus 7 equals 4. I'm sorry, we just did that method. We would solve for b, which we would do the opposite. b plus 7 equals 14. Opposite of adding 7 is subtracting 7 from both sides. b equals 7. See how that matches what we have up there, which that also shows us that one's a solution. Last one, plug in 7 in place of b. So 7 divided by 2 equals 14. What does 7 divided by 2 equal? It equals 3.5. That does not equal 14. And then we can try the other method. We would solve for b. So the opposite of dividing by 2 would be multiplying both sides by 2. b would equal 28, which of course does not equal 7. So that one would also be no. All right, that's how we determine if something is a solution to an equation. Let's move on to number 5. 5 says, consider the inequality m is less than or equal to -8 and graph it on the number line. It also wants us to determine whether it's a solution or it makes the inequality true by selecting yes or no and showing work. All right, so starting off here, we know our inequality is m is less than or equal to -8. So I can place -8 and build up and down from there. Remember, negatives have opposite rules, so part of my graph needs to be that it's not -8, -9, it's -8, -7, -6, and then building the other way. Since this has an equal to, my circle is going to be shaded because it makes it a solution, right? If I plugged in -8, -8 is less than or equal to -8. And then I'm shading to the left since I want all values less than -8. All right, over here I can just plug in. So plug in values in place of m. -3 is less than or equal to -8. -17 is less than or equal to -8. 8 is less than or equal to -8. And -9 is less than or equal to -8. Now I'm going to go back and evaluate if those are true or not. So remember, the mouth always wants to eat the bigger value. So is it true that -3 is less than or equal to -8? -8 is not bigger than -3. You would rather have 3 problems compared to 8 problems, right? So that one would be no. What about -8? Is -8 bigger or equal to -17? Yeah, you would rather have 8 problems compared to 17 problems, right? So that one is true. What about -8 being bigger or equal to 8? No, positives are always greater. So that one should be going the other way. And then what about -9 being less than or equal to -8? Means -8 is bigger. Yes, you would rather have 8 problems compared to 9 problems. So that one's true. And those are numbers 4 and 5.